Hello, everyone, and welcome back. So we're looking at solving exponential equations with a common base. Let's have a look at this question over here. It says, solve the following exponential equations, and we want to solve for x, basically. Anytime you're asked to solve, you're basically solving for the variable or the unknown. And so over here, we're trying to solve for x. We can see that these two have that common base. And so basically, the only thing that we're interested in is because they're already the same base, then the only way these two sides could be equal is if the exponents are equal, right? So I need 5 to the power of something is equal to 5 to the power of something. And so over here, I'll have 2x plus 3 is equal to 7. If I want to solve for x, I just isolate. So I have 2x is equal to 7 minus 3. That's 4. Divide by 2. Divide by 2. Then I have x is equal to 2. Okay? All right, let's do the next one. So the next one over here is 7 to the power of x minus 2 is equal to 343. That looks kind of weird because you're like, oh, okay, well, how do I solve for x? X is in the exponent. And what you can do over here is you want to first check, can I have a common base? Which in our case, this is the topic. So even though, even if you didn't have the heading over here that we're doing common base, then you want to think, can I write this as a common base? Okay. So 343, when you test some numbers out, so you go, oh, okay, 7 to the power of 2, that's 49. What if I go 7 to the power of 3? That's 49 times 7, which gives us 343. Okay. All right, so sometimes you're going to need to test some things out because you might not know all the like exponential powers of a certain number. So over here, you're going to go 7x minus 2 is equal to 7 to the power of 3. Now that tells us that these two exponents need to be the same. So we're going to go, oh, okay, because of that, we're going to have x minus 2 is equal to 3. That means that x is equal to, move this to the other side, or you can just go, oh, well, what subtracts 2 to give me 3? That's 5. Okay. All right, let's do this last question. And for the last question, actually, I want you to pause the video, try it out on your own, right? It's always nice to give it a go before you see someone solve things. So try out the next one on your own and then come back and join me, okay? All right, go ahead. Okay, so now that you're back, let's have a look at this together. Now, we've already talked about 81 in terms of 3, that's 3 to the power of 4. So we can go 3 to the power of 5x minus 1 is equal to 3 to the power of 4, that's 81, all to the power of 3x, right? And then in that sense, we're like, oh, okay, we're getting there because we have that same base, right? So we'll have 3 to the power of 5x minus 1 is equal to, I need to simplify this exponent first before I can go, oh, that's equal to each other. Well, actually, you don't really need to, but it is useful to have simplified exponents. And so we'll have 4 multiplied by 3x, that's 12x. Oh, my bad. I need to write that as an exponent first, 12x. Now we can say that the exponents are equal to one another because that's the only way that would make both sides equal is if these exponents are equal to one another. And now we solve for x. So move the 5x to the other side. We'll have -1 is equal to 12 minus 5, which is 7x. Divide by 7. Divide by 7. X is equal to -1 over 7. Okay. And that is the x that gives me our answer. And that's the x that makes these two sides equal. Okay. All right, everyone. I hope you got the same answer as I did, and I'll see you in the next video. Bye.